So in the transmission media, we have seen there are mainly two types: guided, unguided. Again, guided media again is of three types: twisted pair, coaxial, fiber optics. We will try to understand now the twisted pair guided media properties. A twisted pair, so it is a popular guided media. So the twisted pair, consists of two copper wires. It consists of two copper wires, typically about 1 millimeter thickness. Each wire is of 1 millimeter thickness. These wires are twisted together. These two copper wires are twisted together to reduce the noise. So due to the twisting, the crosstalk will be reduced. Again, the twisted pair, there are mainly two types of twisted pair cables available. There are you can classify again twisted pairs into two types. The first type we call it as shielded twisted pair. Second one is unshielded twisted pair. We also call the shielded twisted pair as STP cable, shielded twisted pair. Similarly, unshielded twisted pair as UTP cable, unshielded twisted pair cable. Typically, the bandwidth of a twisted pair cable is a few hundred Mbps to around 1 Gbps. It will support bandwidths up to few hundred Mbps to 1 Gbps. The difference between the shielded twisted pair and unshielded is the pictorial. I will draw a picture. This is assume unshielded. As I told you, this is the outer plastic covering. Assume outer plastic covering. So two copper wires. This is the first copper wire. Two copper wires. Are twisted together. So this is an example of unshielded twisted pair, the pictorial representation. If you see the shielded twisted pair, this is the outer plastic covering. Assume outer plastic covering. The two copper wires. This is the first copper wire. This is the second copper wire, are twisted together. This is nothing but it is like a metal shield. It is a metal shield. So the shielded twisted pair will give more protection than unshielded, especially when there is a high chance of electronic interference, such as radio stations. Shielded twisted pair is preferable. So the only difference between the shielded and unshielded is there is like a foil structure. Again, these twisted pair cables inside the a foil like structure, inside like a metal sheet. There are many applications. The popular applications for twisted pair cables, the popular applications, basically the earlier all the telephone lines, all the telephone lines, the all the telephone lines are twisted pair cables. Basically assume you want to construct a LAN inside your home or an organization. Normally we go for unshielded twisted pair. So for LANs, the twisted pair cables are more useful. Basically we use unshielded twisted pair to construct a LAN. If you want more protection, especially if there is a high chance of electronic interference, such as like in radio stations, normally we go for shielded twisted pairs. The second type of guided media is the coaxial cable, coaxial guided media. The second type is coaxial. Guided media. So compared to the twisted pair, the coaxial cable has the better shielding. It has better shielding compared to the twisted pairs, and also the coaxial cable supports the greater bandwidth than the twisted pair. So it supports greater bandwidth compared to the twisted pair. So as it supports the greater bandwidth, normally coaxial cable will be helpful for sending data a longer distances. So it supports longer distances. Suppose we want to send data longer distance, coaxial cable is more preferable. If you see the coaxial cable, assume this is the outer plastic covering. This is assume outer plastic covering. This is like a metal shield, like a metal shield. So this is the copper wire. Whatever you are seeing, this is the copper wire. Copper wire acts as so this is the in fact copper wire. Copper wire. This is, it acts as one cable to transmit the data. This is the metal shield. This is like acts as the second cable, metal shield. Yeah. So the coaxial cable supports the bandwidth up to, as I told you, the coaxial cable is having better shielding and also supports greater bandwidth compared to the twisted pairs. So the bandwidth supported by coaxial cable, it is up to a few gigahertz. The popular applications for coaxial cable, the first one is cable TV. the cable TV. The second, suppose assume you want to construct a metropolitan area networks, the coaxial cable only preferable, because it provides the higher bandwidth, so it can support up to data transfer up to longer distances. The third type of guided media is a fiber optics. Fiber optics. So the third type is fiber optics. The fiber optics is like a it is like a glass. It is like a glass structure. So due to the glass structure, it acts as like a waveguide. It acts as like a waveguide to transmit the light signal from one system to another system. Means that in the context of the fiber optics, data is transmitted in the form of light pulses. So the fiber optics looks like a glass, hence it acts as a waveguide to transmit the light signal from one system to another system. Means here the data is transferred in the form of light pulses along this glass. Mainly the fiber optics has two layers. The fiber optics has two layers. The first layer we call it as core. This is only used to transmit the data. The second layer we call as a cladding. It is just like a shield. It is just like a shield, metal shield, whatever we have discussed in the previous, like it acts as like a shield.